Now we are going to move from functions to binary relations. Binary relations are generalizations of functions. You already knew functions, but in this chapter, we learned functions from a set theoretical perspective. Similarly, you kind of already know what binary relations are, even if you have never heard the term. And now we're just going to make it more formal and precise using mathematical notation. So what is a binary relation? A relation between sets A and B is just a subset of A cross B. That's it. Very simple definition. And you already know an example, function. Recall that a function from X to Y in set theoretic notation is a subset of X cross Y, which satisfies certain property, that is for every X in X, there is a unique Y in Y such that this was a set theoretic definition of function. And you can see F is a subset of X cross Y. So F is a relation between X and Y. So functions define relations, but relations don't need to have this extra condition. So they can be much wilder than functions. Having said that, we don't really study binary relations that much between arbitrary sets. Instead, we'll focus on this special case. A binary relation on a set, a single set. A is just a subset of A cross A. So here, both the sets are the same. And again, let's say R is a subset of A cross A. Now, this is a remarkably useful definition, and it shows up everywhere in mathematics. There are so many structures which are secretly binary relations, but we don't really think of them as such. For example, as we just saw above, a function is a binary relation, but it's not like we think of a function as a relation. There is a nice way of representing a relation. It is denoted ARB, and we say ARB stands for A comma B is a subset of R. So if R consists of pairs of elements of A, and if the pair A comma B belongs to R, then we denote it as ARB, and we read it as A is related to B. Hence the name relation, and binary because it's relating two things, and binary usually in math stands for two. And there is a very nice pictorial way of representing a binary relation. So let me do a simple example. Let's take the set 1, 2, 3. And I'll just randomly create, let me do 1, 1, 1, 2, 2, 1, and let me do 2, 3. Why not? So I can describe this binary relation using a graph. And how do I do that? I create a graph whose vertices are the elements of my set. So I have 1, 2, and 3. And then for every pair in the binary relation, I draw an edge starting at the first element of the pair and ending at the second element of the pair. So that will look like this. The first element is 1, 1. So this is encoding the fact that 1 is related to 1. Second is 1, 2. That I'll draw like that. Then the third element is 2, 1, which I'll draw like this. And finally, the fourth element is 2, 3. Okay, so binary relations can be encoded using graphs. A very simple example. Now let me give you some concrete mathematical examples which are secretly binary relations. We saw one already, which was a function, and now let me look at less than. Less than is a binary relation. Why? So less than, I can say, consists of subsets, consists of pairs of natural numbers A and B, such that firstly A and B are natural numbers, and A is less than B. So let me write a few elements. So the elements will look like 0 is less than 1, 0 is less than 2, and 1 is less than 2, 0 is less than 3, and so on. Of course, there's an infinite number of elements, and I can't write them all using the roster notation. I have to use the set builder notation. But I can try to pictorially describe it, and it will look like this. So I have my set of natural numbers, 0, 1, 2, 3, and then 0 is less than 1, so I'll have an edge like this, and I'll have an edge like this. Then 1 is less than 2, I can describe it like that. And 2 is less than 3, let me use black, so it'll be like that, and so on. And you can see this will be a very complex graph, but less than is a relation. And we say this in words anyways, A is less than B. You're actually encoding A is related to B by less than. You can have divisibility. You can have the relation R defined as A and B, where A and B are natural numbers. And A is related to B if A divides B. So the relation of divisibility consists of pairs A and B such that A divides B. And this is a relation. This is how numbers are related to each other. And what are some elements in here? You have to be careful. A is dividing B. So 1 divides everything, and I get 1, 1, 1, 2, 1, 3. Similarly, everything divides 0. So I'll get 1, 0. I should have started with 0 there. 2, 0. 2 divides 4, and so on. Again, there are infinitely many elements. I can't really describe them using the roster notation. But I can draw an approximate graph, and the graph will look something like everything divides 0. So that gives you arrows going into 0. 1 divides everything. So that gives me arrows going out of 1 to everywhere. I already have captured the arrow to 0. Then 2 divides 4, but 2 does not divide 5, but 2 divides 6. So these will be arrows that look like this. 3 divides 6, so I'll get one more arrow from 3 to 6, and so on. So divisibility is itself a binary relation. In fact, every time you have a statement that says something, a mathematical structure related to another mathematical structure, you are secretly dealing with relations. Now let's do some real world examples. Suppose I take my set A to be, let's say, all the students in this course. This is a valid set. And I can take my relation as follows. A and B are in R if they have the same age. And another way of writing this is ARP. So A is related to B if A, B have the same age. So having same age is a valid relation. Another very practical example is being friends on Facebook, let's say. So you can have A is the set of all people with Facebook accounts. The relation is AB, that A and B are Facebook friends. This is a valid example of a relation, and you would say A is related to B if they are friends on Facebook. So these are some examples of relations. Oh, I made a mistake in one of the previous examples. In divisibility, 1 divides 1, 2 divides 2, 3 divides 3, and so on. So I should actually also have these loops in here. Sorry about that. So these are examples of binary relations.